Hi everyone, Unit 2, Limits, Subsection 6, Using Limits to Find Tangents. Part 1, Finding the slope of a tangent line at a certain value. Okay guys, recall from subsection 1, the tangent problem. It was difficult to determine the slope of the tangent line because it was difficult to find the slope of the line when there was only one point. We got around that problem by finding slopes of multiple secant lines as the second point got closer and closer to the tangent point. Essentially, what happened was we were finding the limit of the slope function as x approached the tangent point. Okay, so I want you guys to have a look at this picture. So we're going to, if I want the tangent line at this point right here, we can say this is the point A and f of A. Okay, and then this point up here, well, if the curve is y equals f of x, then this can be thought of as whenever we have the point x, then the function is f of x, or the y value, pardon me, is f of x. Okay, so that makes a second point. Okay, so now if we use this to apply our slope formula, remember slope is just y2 minus y1 over x2 minus x1. Okay, well, look, this is now our second point, right? So that's y2. So your slope is f of x minus f of a, all divided by x minus a. Okay, so that's the slope of the secant line, right? Well, the whole point of this is to get multiple secant lines closer and closer and closer to the tangent point. So, guys, what we've been preparing you for is the slope is the limit as x gets closer to a of this above formula. So f of x minus f of a divided by x minus a. Now, if we look at this, right, as x gets closer to a, we're going to have f of a minus f of a, which is 0, minus a minus a, which is 0. So it makes a 0 over 0 limit. Okay, so we're going to have to do some factoring to get rid of the 0 over 0, but that limit will be the slope of the tangent line. And we don't have to use charts, we don't have to use tables of values. Okay, it's just a nice, neat little formula. Okay, so let's give her a try. Okay, so example 1. Find the equation of the tangent line to the parabola y equals x squared at the point 1, 1. Okay, so there's our formula. Slope is limit as x approaches a of f of x minus f of a over x minus a. All right. Well, okay, what does this all mean? Okay, so here's the tangent point, 1, 1. Okay, so this is, a value is 1. So f of a is also 1. Okay, the x and the y value of the point of the tangent point. Okay, so now this point up here, that is any point on the whole graph. So that's just x. And what's f of x? So f of x is just the function. Okay, so this is y equals x squared. So f of x is just x squared. So there's our second point. All right, so now to apply the slope formula, we go y equals the limit as x approaches 1, right? Because a is 1. Okay, so then f of x was x squared. F of a is just 1 over x minus a. Well, a is 1. Oh, so the slope is the limit as x approaches 1 of x squared minus 1 over x minus 1. Oh, well, that's not so bad. All right, so to evaluate these limits, remember we always start by putting the number in. So 1 squared minus 1 is 0. Okay, and then 1 minus 1 is 0. Oh, okay, so it really is a 0 over 0 limit. Now, funny thing on these ones is these ones will always be 0 over 0 because it's always going to get to be closer and closer and closer to that tangent point, right? So, of course, it's going to be 0 over 0. All right, anyways, so to solve for this thing, remember, to solve for 0 over 0 limits, we have to figure out some way of factoring to cancel out the 0 over 0 part. And it just so happens that x squared minus 1 is a difference of squares. So x minus 1, x plus 1 over x minus 1. Okay, so those cancel. There goes the 0 over 0 part. And we end up with the limit as x approaches 1 of x plus 1, which now works, because if you put 1 into that, okay, well, that's just 1 plus 1, which equals 2. So look, the slope equals 2. So slope equals 2, and our tangent point was 1, 1. So through 1, 1. So, and remember, we're using the point slope form for all of these because it's easiest. So that's the y minus y1 equals mx minus x1. Okay, and you can use y equals mx plus b if you really want, but this is the form that we're going to use. This is the form your university profs are going to want to see. So y minus 1 equals the slope, so that's 2, and then x minus 1. And that's it. There you have it. There's the slope of your tangent line. Just for the fun of it, if we have a look at our graph, and I'll do a little bit of erasing here. If we have a look at our graph, okay, so it goes through 1, 1 and has a slope of 2. So that means 2 up, 1 over, 2 up, 1 over. And let's go 2 down, 1 left. So about there. And there's our tangent line. I'm off a little bit, but with a ruler, I mean, you would see, like, that's pretty close, right? To, like, eyeballing a tangent line, like, hey, we're bang on. All right. Example 2. Find the equation of the tangent line to the cubic function y equals x cubed at the point 2, 8. All right. So, in this case, the tangent point, that's the a, so a equals 2. So f of a equals 8. So the other point comes from the equation. So it's just a general point, so x equals x, and then y equals x cubed. So there's our point. So we're going to try and find the limit as x approaches a, so as x approaches 2, of the slope function. So that's going to be x cubed minus 8, right? The 2y coordinates subtracted, minus x minus 2. Okay, and nice. So we put in the 2. 2 cubed is 8. 8 minus 8 is 0. 2 minus 2 is 0. So this really is 0 over 0. Okay, and they're all going to be that this time. And oh, look, the top part is a difference of cubes. Man, it sure is good we taught you that way back in Unit 1. Okay, so limit as x approaches 2. I know this seems annoying, but it's still a limit, so you still have to put that. Okay, so remember, difference of cubes. Okay, if you forget, hey, this is the beauty of this. You can go back and look. But anyways, so you take the cube root of x, the cube root of minus 8. Okay, so that's the first chunk, cube root, and keep the sign. Okay, keep the minus sign. And the second chunk is, okay, you square the first, so that's x squared. Then the next one is these two times together, the x and the minus 2. Okay, well that is 2x. Now remember, for the second chunk, you change the sign. So it was a negative, so now it's a positive. Okay, and then the last one squared. So negative 2 squared is plus 4. So that's how you factor the top. Okay, and then of course x minus 2 you can't do anything with, and then you cancel. Nice. So the 0 over 0 is gone, and the 2 will just go into the part that's left, so the slope will be 2 squared plus 2 times 2 plus 4. Okay, well, 2 squared is 4, plus 2 times 2 is another 4, plus another 4, so 4 plus 4 plus 4, so the slope equals 12. Nice. Then, of course, now it's easy because it's y minus 8, y minus y1, equals the slope, 12, and then x minus 2. There you go. Sweet. Okay, let's try one more. Okay, let's find the equation of the tangent line to, ooh, it's a bigger function. Wow, that's crazy. At the point 2, 0. Okay, so again, a equals 2, f of a equals 0. Then we have, or apply the general point. So if we have the point x, then this would be the y-coordinate, okay, at x. So x squared minus 3x plus 2. Sweet. Okay, well, let's carry on. So the slope is the limit as x approaches, okay, well, a is 2. And this formula will be given to you on like the tests and whatever, so you don't have to memorize it. You will memorize it, but not a big deal. Okay, so then f of x is x squared minus 3x plus 2 minus f of a, oh, look, minus 0. Wow. All divided by x minus 2, right? Because that was x minus a. All right, so again, 0 over 0, okay, 2 squared. 2 squared is 4. 2 times 6 gets 4, minus 6 is negative 2, plus 2 is 0, minus 0 is 0. So this thing really is 0. 2 minus 2 is 0. Okay, fair enough. All right, carrying on. Oh, well, if this is just the limit as x approaches 2 of x squared minus 3x plus 2 over x minus 2. Now remember, this point here is just whatever the y-coordinate of the tangent point is. If it's not 0, well, you subtract a different number and it just combines the like terms, right? But we didn't have to worry about it this time. So let's carry on. So we're going to factor the top. Just 2, so we have factors of 2 that add to 3. So 2 and 1, and they're both negative. Oh, well, look at that. So the x minus 2's cancel. The 0 over 0 cancels. So the limit here is just, we put the 2 in, so 2 minus 1. So the slope is just 1. Oh, nice. Okay, no big deal. So now we have y minus y1. So, oh, y minus y1, hey, that's just y minus 0. Look, guys, you really don't need to put that. Okay, so the slope is 1. You don't really need to put that either. And then x minus 2. So let's clean this up because we don't need a lot of stuff. Okay, so the 0 we don't need, and the 1 times anything we don't need. So this is just y equals x minus 2. Beautiful. We don't even need the brackets there when there's nothing to multiply. So there's the slope, or sorry, pardon me, there's the equation of the tangent line. Now, I'm going to read this little snippet at the bottom. Notice how most of the work is done in finding the slope. That's all that up here. Now, if I'm going to ask you something like, hey, find the slope of the tangent line at 4, 6, you would have to go back right to the beginning and say, okay, a equals 4 and f of a equals 6, and redo all this work to get the new slope. Okay? there should be a better way, and of course there is. Of course there's a better way. And we're going to show you that in part 2. Thanks, guys.